Hey guys, and welcome back. So I have the sim cached for the points, and this is how it looks like. Currently we have a lot of points, that's why it's taking a while to read them in. What I should have done is delete everything that is black and just keep the active points, but we're going to rewrite it anyway, and so we'll do that in the next video, or the next time. Okay, so everything looks like it's working, and what I'm going to do is I want to isolate only the points that are white. And let me check. Okay. So let's delete everything except these guys. So we have a lot of pieces actually. And what I'm going to do is, remember we have that main name attribute as well as the name attribute. So if we go to the objects, where would that be? This guy. No, after the upres, this part. And we made the name attribute, so let's call this named upres, and let's import this. And let's make sure it's unpacked data. Cool. And we have the name attribute. So now we can copy data from these guys, from these points, onto these pieces. And even if one piece, let's take a look at one area. I want to show a small section. This is all the points, but if, for example, one piece had one of its points get flagged with white, that means it's going to become active, okay? Because we're only keeping that point from that piece. Even if it has 10 points total, if one of those points becomes white, it gets flagged to become active. So what I'm going to do, to show you this better, I'm gonna set the colors here, and I'm gonna copy the color between the points from these points onto the geometry. And instead of using the match by, we're gonna use the name attribute. So again, it's not gonna work because the name attribute is not a primitive, it's not a point attribute, so we need to promote that from primitive to points, and we don't want to delete the original. And now we have the activation copied into the mesh. So if I play through this, you will see that pieces are going to become active. And I think it's actually a lot of points here. I think it's too much. I want to see the core state kept in there. So there's some of it here, but overall I think it's going to activate everything, so basically everything will go into the smallest, finest amount of details that it can have. Okay, so this is fine. I mean, this is where we have to tweak things. And what we're going to do now is we're going to use this information to trigger the activation attribute. So let me do this. Let me assemble this guy. I want to pack it. No need for new name attribute, I just want to pack the geo. Okay. And I'm going to delete. I'm gonna only keep a few pieces. I mean, yeah, that's fine. Okay, I don't need this because it's at the point level now. And these guys, we're gonna give them an active attribute of 1. Attribute wrangle I at active equal 1. Okay, and then here we're gonna set everything to be active 0. And let's copy the active attribute, the active attribute. And we don't need the color. And let me blast just to see that, make sure that everything is working. Yep. So this is the inactive and these are the active pieces. If we go to frame 0, it's gonna start turning on geometry. So this is great. The next thing we need to do is, let's call this text activation. The next thing is we need to transform this using the same RBD, the same transform thing. So let's copy this. And this is our sim points. We're going to keep that. And we're going to connect this here. And remember, we need that main attribute. And after the packing, we lost that. So we need to restore that guy. Okay, so that's our geometry. And remember, they are getting activated. So even if we see this, it doesn't mean it's gonna look like that once we start simming. And the other thing that we need is, from the previous example, we need the animated attribute. So basically, when a piece has an active attribute set to 0, we want it to be following this kinematic. We want it to follow this motion. If it's active attribute, pardon me, if its active attribute becomes 1, then we want to flag or want to change the animated attribute to 0. So let's write that into a wrangle node. I at animated is equal to 1. Everything that's the default. If the active attribute is equal to 1, then the animation is off. That's the logic we want. Okay, and we're gonna call this out upres RBD, and again RBD upres. And sorry I've done this so much, but I'm fine with this. Let's do a ground, let's do a gravity node, and let's do a merge node. Let's call this a press main. I'm gonna keep these two guys as that doesn't matter this at this point. We just need the active and animated thing. Let's go back. And let's scale this. I think it's best if we scale it by 20 units as well, but let's see what's gonna happen. Also, it's, you know what, I'm gonna do something super quick. I hate this slow caching. So I'm gonna cache this super quick. I mean, it's not super quick, but after it writes the cache, we're gonna be able to read this super quick. So let me pause while this finish, and then we'll continue in a second. Okay, so the cache is done, and I'm reading it through this read node, and this is the points. So we're copying that onto these guys. Okay, and let's take a look. Hit play. And we should see it transform. Yep, and then it's also activating. So it's working. Yep. And you can see how it's eroding the pieces, and I think it's too much. Yeah, everything went into the smallest amount of details you can get. See it here too. And so this is very nice crumbling effect that we get with this method. We can definitely increase the transfer attribute and have it propagate even if the geometry is not separating. It could lead to very, very interesting effects like this one. Let's take a look. And remember, right now the geometry is becoming active and we're not introducing any collision. So Kong and all the other anything else that we had is not in the scene. So once the geometry becomes active, it's just following the initial velocity that it inherited from this. And we need to include all the other parts of the system. It's not just these guys. But let's do a play blast of this. I think it's too much, obviously, but let's do this up until 140. Oh, sorry, I need to change the settings for this guy. Yep, you see how it's separated, and I mean everything is clear, I'm sure. And this at this point, the setup is pretty much done. We just have to tweak the settings so we don't erode the geometry too much, otherwise this is what will happen. And then we can definitely increase the amount of details on here. We can increase the number of pieces, and then we can also I'll talk about this later, but we can do a secondary fracture on top of this, another one. So we did the upres and we added details all over. We can do another loop and isolate the outer layer, only the outer pieces, and fracture those again. So this way we have super tiny fracture at the edges, and then it gets a bigger and bigger, and this will make it look more interesting for sure. And that's something you guys can explore. Okay, let's hit play. Cool, so it's working. I really like the crumbling here. Okay, so what we're going to do now is we can add Kong, but let me check the scale first. Okay, the scale is correct. We did the scale here. Cool. So we can copy Kong. And that's pretty much all we need at this point. Okay. And I'm gonna do we're gonna improve the activation system. So another thing that is nice to have when a piece of geometry, let me show it here. When we have something hitting the ground, what happens to it is its velocity changes direction in a frame or two. So let me find one. Okay, I'm gonna isolate one piece. Perfect. So see how this guy does this? It hits and then changes. I'm gonna unpack this. And let's take a look at the velocity vector. And it's not inheriting the velocity from these guys, so let's transfer that. And look at the velocity vector. It's going in this direction, and then in one frame, it changed. Look at the difference there. Boom, boom. That's called an impulse activation, or an impulse where the velocity changes direction quickly. And this is a great way to use, this is great information to use to trigger activation. Okay, and what I'm going to do is I'm gonna use this information to activate the pieces, and as the geometry rolls, when that happens, I'm gonna use that state to flag the geometry to become active. Now obviously if it had already been activated and there is nothing much left to activate, nothing is gonna happen. But if it's still a solid block and we hit the ground at that state, it's gonna activate all the surrounding, and we can actually find even that spot. So let's do this. Let me scatter a lot of points onto this to better illustrate the idea. And I'm going to use a time shift. So what we're looking for is a change in velocity, and I'm going to look at the previous frame. So this is the current frame, and this is the previous frame. I'm going to create a point VOP. And this is our current sim, current input. And I'm going to import the velocity from the second input. So import point attribute. And we want to import from the second input. And for some reason it is slow, so I'm going to turn off the live update. And I'm going to subtract the current velocity from the previous velocity. And this is going to give me a vector. And then I'm going to compute the length of that vector, and I'm going to plug it into the color. So let's go back. There, that's white. And that's white. And then it's, let's set the color here to black. Okay. And let's take a look at the values. So we have something that goes between, it's 0 here, 25 here, 9 there. So we need to remap this guy. So let's put down a fit range. Let's go to this frame, and let's remap the velocity, the length of this guy between 10 to 25. Pardon me. And look at this. Now we're getting a flash when this condition happens. See, nothing happens in all of this. Well, there, that's one state, and then this. So we're going to use this information on top of what we have to flag the geometry as well. But we don't want this to happen everywhere, because I don't want these pieces to become active. I only care about the stuff that is close to the ground. So we're going to use the height as another multiplier, and let's find good settings there. I think that's already a good setting. So something like that. And I'm going to use this as a multiplier. And now we're only activating stuff that is close to the ground. So all those guys will get flagged. Let's do 30. Yep. And another thing that we're going to copy this obviously and try it on the main setup. And that would be, let's see. So after the at this point. This is where we want to do it. So these guys, we want to do it at this point. Do we have velocity vector? Yes. So let's paste in. And I think it's working. Yep. And let's tweak the settings, maybe 5 to 15. And we're doing 2 frames now, so it's a bit trickier. And let me check about that cost attribute that we did. See if we have that cost attribute. So let's see if we can use that to safeguard the core of the sim. I'm going to use a file cache just to temporarily cache the data here. Okay, let's cache it here. Okay, and let's use a color node and preview the cost attribute. See if we can get anything. It's actually, there's quite a bit of useful information there. Yep, it's definitely, it has the right amount of information we need. So I'm gonna use this, and I'm gonna plug it here and use this guy as a multiplier. Vector to float. And no, actually let's import let's import from the third input. And let's make sure it's working. Cool. And we could also use the same thing here. And I'm gonna create another one after remapping it. So f equal cost is equal, I'm gonna read the second input color, ptnum. So it's a vector. Input. And this is just a quick way. Cost mask is equal input dot x. Okay, so now we're reading the color from here. I'm gonna use this as a multiplier inside the solver. So we're going to multiply CD by the limit and by the f cost mask, so both. And we're also going to combine these two guys. So let me move all of this. So we have this going, which is great. Oh, actually, one more thing. I want to reduce this guy. I want to reduce the transfer. Yeah, something like that. Maybe 3. And I want to combine this result with this result. So I'm going to use a point VOP. And the color information, actually we need to turn these off. The color information, we're going to import the color from the second input. So import point details, point attribute CD from the second input, and I'm going to use a max function between the current color, the second color, and I'm going to clamp that between 0 and 1. And this way it's going to combine the color from both inputs. We just have to make sure that we get we get enough white so that we don't delete the information. I think this, I'm gonna multiply this by 3. The color here is very low, and we're not gonna be able to use that. Yeah, so something like that. And let's write this as V2. And this is pretty much it. I don't have anything else. We have to be careful with not eating out the entire geometry core and only activate the necessary pieces. We have to balance the amount of details we have versus how much we're activating, and also about the appraise idea. Right now we're doing this fracture. We can use we can group the pieces at the shell, or actually we can group them using the cost attribute, for example, or using generating a point cloud scatter nodes and just transferring an attribute, transferring a color attribute and isolating the closest pieces, and then doing a secondary fracture on top of those. So I can select these guys, or maybe when we have better, something like this, we can isolate the outer geometry and subdivide that even further. And so this way we get a lot more details and less of the outer layer and less details in the center. So that's something to explore, and I would definitely recommend playing more with the pattern here. I mean, we're just doing a simple fracture. We could even do a layered fracture onto this one, which that would make it look really, really cool, but I haven't done that. So instead of just one layer, we could fracture this into 3 pieces, and then those 3 pieces we could fracture them again, and so on and so forth. And we always keep scattering points at the outer layer more than the rest of the geometry, and this will create definitely more interesting pattern. When it gets really small, we have to be careful with the amount of noise we add, because it can easily start creating interior edges here. So that's something we have to be careful with. Okay, let's do the caching. I'm gonna delete the points here, and this is actually what I'm going to do. I'm gonna write this as V2, and we're gonna use this to do another quick test, and then we're gonna move on to a different geometry, and we're gonna use a different activation technique for this geometry. Thank you guys for watching, and see you in a bit.